solubility of gases in liquids. So here also, as we discussed in the case of the solids in liquids, here also the solubility of the gases in liquids depends on the conditions like nature of gas and solvent. Condition number 2 is temperature and 3 is pressure. So let us discuss about the nature of gas and solvent. Here, first of all, let us take the solvent like polar and non-polar. So I am taking the water and benzene. Benzene or CCl4. So we are going to discuss mainly about the water molecule, and this we shall discuss later. And nature of the gas. So here gases are of two categories. They are easily liquefiable gases and non-easily liquefiable gases. So what are the easily liquefiable gases? The gases which can be liquefied very easily are known as the easily liquefiable gases. Usually the gases with polar bonds are easily liquefiable. Second one is if they are able to form the hydrogen bond, then they are easily liquefiable gases. And third, higher molecular mass. In this condition is subjected to the various gases, that depends. So higher molecular mass is there, means they also can be solved because 1 to all 4s are more there. Non-easily liquefiable gases, that means these gases cannot be liquefied very easily. Such type of the gases are known as the non-easily liquefiable gases. So these are not having any polar bonds, completely non-polar molecules. And a smaller atomic size or smaller molecular weight and atomic size. Usually they are the non-easily liquefiable gases. Let us take the example for the easily liquefiable gases. Example, HCl easily liquefiable, ammonia easily liquefiable, SO2 easily liquefiable, etc. These gases can be liquefied easily because they can develop the attraction forces very easily. Non-easily liquefiable gases. These gases cannot be liquefied very easily like H2, helium, oxygen, nitrogen, argon, etc. So these gases needs even lower temperatures, minus temperatures, then they can be liquefied easily. So easily liquefiable gases are more soluble in the water than the non-easily liquefiable gases, and moreover the gas whichever we are going to take, if it is able to react with the solvent, then its solubility is higher. If it do not react with this solvent, then its solubility is less. Now if we take the hydrogen chloride, so hydrogen chloride gas, when you add to the water, then it forms hydrochloric acid. So it is more soluble. And when you add the ammonia gas to the water, it forms ammonium hydroxide, so that it is again more soluble. And if you add SO2 to the water, it reacts with the water and form the H2SO3, so that is also more soluble. Means easily liquefiable gases not only can be liquefied easily, if they are able to react with the water, then their solubility in the water shall be very high. And non-easily liquefiable gases, these gases cannot be liquefied easily because of smaller molecular mass, smaller atomic size, Smaller atomic size means attraction force is also very less. So that's why their liquefaction becomes very difficult. And if these gases are not ready to react with the solvent, then they are also not soluble in the solvent. So here, nature of the gas is affecting the solubility. Similarly, when you take the HCl gas and try to dissolve in the benzene. Benzene is a non-polar compound. Hydrogen chloride is a polar compound. Then though it is a gas, but it is completely insoluble in the benzene because polar and non-polar, that is what like dissolves like concept here. So non-polar polar compounds or polar gases are insoluble in the non-polar compounds. This is about the nature of gas, how it is going to decide its dissolution in the given solvent. Now let us come to the concept of the temperature. So let us take a diagram here. So this is some water is present along with some oxygen is present in that water. So your condition is, whenever you are heating this, any particular liquid, starting these molecules separate out and they go into the vapor state. Means conversion of liquid to its gaseous form is an endothermic process. That means we are giving temperature. When temperature is given, when energy is given, then only liquid shall be converted into the gaseous state, otherwise it will not convert. So the conversion of all liquids into their gaseous forms is an endothermic process. We are discussing about the dissolution of gases, the solubility of gases in liquids. Means reverse process we need to do it. Means we have to send the gases from outside into the liquid so that we have to make sure that the gas is dissolved. Then we are doing the reverse process. So the dissolution of gases into the liquid must be exothermic. Why? Because gas molecules always with a higher energy. To convert these higher energy molecules into the lower energy molecules, you need to remove some amount of energy. That is the reason why the dissolution of gases in any liquid is always exothermic process. Now, let us take two conditions. What happens if temperature is increased? If temperature is increased, it favors sending of the gases out of the liquid, so that solubility of the gases in liquid gradually decreases. And what happens if temperature is decreased? If temperature is decreased, that means you are removing the energy, excess amount of energy, so that higher energy molecules can be converted into the lower energy molecules. So the solubility of the gases in the liquids gradually increases. So this is the reason why the fishes, aquatic life, fishes and all these whichever stay in the water, they feel very comfortable during the winter season rather than in the summer season. Because in winter season the temperature falls down, so that the water also gets cooled, so that it will have the more amount of the oxygen dissolved, so that they get the more amount of the oxygen. Hence they always spend their most of the time at the deep of the water during the winter season. And summer season, when temperature rises, whatever the oxygen dissolved, that starts coming out, so they don't get the more amount of the oxygen, they feel completely discomfort. To get the more oxygen, they travel to the upward of the water levels, so they always stay in the upper layers of the water. That is the reason why fishing becomes very easy during the summer season rather than the winter season. So this is the effect of the temperature on the solubility of the gases in solvent, water. Now let us take the effect of pressure. How this pressure can affect the solubility of the gases in the solvent. So the pressure effect, the relation between the effect of pressure and the solubility of the gases was given by Henry, that we call as a Henry's law. So he has taken an experiment in which a liquid is placed and a piston is placed above that, and here some amount of the gas is present like this. So when piston is moved from here to here, that means when you are applying the pressure, initially the gas molecules come close to each other. Again, when you apply the pressure, when there is no chance for the gas molecules to escape, when they have only one chance to dissolve into the water, then automatically their solubility increases. That means initial stages, here gas molecules in the undissolved form, some amount of the gas whichever is dissolved in the water are in the equilibrium stage. By applying the pressure, more gas molecules try to dissolve into the water and new equilibrium is established. Again, when applying the pressure, more amount of the solute can be, that means gas can be dissolved. That means more the pressure you apply, gas has no option to escape, only option to dissolve. That's why gas going into the solution. That means more the pressure you apply, more amount of the gas can be dissolved. Here amount of the gas dissolved into the water or the solvent, we can take it as a concentration. That concentration, now solubility, we can consider it as a solubility. The solubility can also be considered as the mole fraction, as it is independent of the temperature, so that the mole fraction of the gas in the water do not change at a particular temperature pressure. So the pressure mole fraction relation has given the Henry has given the pressure and mole fraction relation. Here we cannot take the molarity or other concentration terms. The reason why we are considering only mole fraction is mole fraction is independent of the temperature, so that at a given pressure, even though temperature changes, the mole fraction do not change, because we are applying the pressure. If pressure is not applied, the gas starts coming out of the solution. So here he has given one relation, that is Henry's law. According to him, the partial pressure of a gas is directly proportional to the mole fraction of the gas dissolved in the given solvent. That means more the pressure you apply, more amount of the gas could be dissolved. Now let us try to replace this proportional symbol using the constant. So partial pressure of the gas is equals to some constant Kh into mole fraction of the gas, where Kh stands for the Henry's constant. And this Henry constant is not constant for all the gases. It depends on the nature of the gas. That's why Henry's constant depends on nature of gas, pressure applied, and temperature. Basically, we can take that it depends on the temperature more than the pressure, so that here we can take the temperature. So how the temperature and nature of the gas are affecting the Henry's constant, let us see here. We know that Kh is equals to partial pressure of the gas divided by mole fraction of the gas. Mole fraction has no units, so that Kh ultimately having the units of the pressure of the gas unit. That means you can take the atmospheres or pascals or bar, whatever it may be. All pressure units can be considered for the Kh. Now, when nature of the gas changes, like here we have taken that soluble gases and non-soluble gases. When more soluble gas you have taken, more shall be the mole fraction. When mole fraction value increases, automatically Kh value decreases. At the same time, when temperature increases, more amount of the gas particle starts coming out. Then automatically mole fraction decreases, so that Kh value increases. That's why Kh value depends on the two factors here, both the nature of the gas as well as the mole temperature of the condition of the experiment where we are conforming this. Now let us see some applications of the Henry's law, where we can apply the Henry's law in the making of the soda bottles or the cool drink bottles. So where you can see that all soda bottles are nothing but the carbonated water. So they take the water and they send some amount of the carbon dioxide under higher pressure. And all cool drink bottles are similar. Only their flavor and taste changes. So for that purpose, they add other ingredients. But basically, they are nothing but the carbonated water. That means carbon dioxide dissolved in the water. So more amount of the carbon dioxide, if you want to dissolve into that particular water, then you need to maintain two conditions. That means you have to apply the more pressure and temperature has to be decreased. That is the reason why on the cool drink bottles, we can see that it was written store under the particular temperature, lower temperature, so that more amount of the gas always stays in the liquid. So in making of there, we can use this Henry's law application. Second one is scuba divers. We know that scuba divers are the persons who go to the deep of the sea for different purpose, adventure and searching purposes. So whenever these persons are going to the deep of the oceans or the sea, they take some oxygen cylinders along with them. So the oxygen cylinders contains both oxygen as well as the nitrogen gas. So when they go to the deep of the sea, above their body, gradually the water level increases. The more deeper they go, the more level increases. When the water level increases, the pressure applied by the water on their body also increases. So when the pressure increases, automatically whatever the gases they have taken, whenever they inhale both oxygen as well as the nitrogen. So both the gases starts dissolving into the blood. If oxygen is dissolved, nothing will happen. Why? Because oxygen can be utilized by the blood for oxidation purpose. But when nitrogen is dissolved, it is of useless because it is not participating in any of the biological activity. So when the person is coming upward direction, so automatically level of the water decreases, pressure drops. When pressure decreases, whatever the earlier nitrogen dissolved in the blood, that starts coming out in the form of these small bubbles. So these bubbles may gather and they may create the larger bubble, which may intervene the flow of the blood, and it may causes sometimes death also. And there is one more thing, that when nitrogen is coming out of the blood, it will give some pain to the body, that is called the bends. So to avoid this, nitrogen is always diluted with helium gas, because helium is insoluble in the blood, or else its solubility is negligible in the blood. So that is the reason why all these oxygen cylinders are always diluted with the helium up to 11%, 11.2% is there. And this nitrogen percent is dropped to the approximately 52.6%. This is the application of the Henry's law. And one more application is there. We know that there are some persons who go for trekking purposes, climbing of the mountains. They take the oxygen cylinders with them. But here reverse process, we can see that. In the case of the scuba divers, they go to the deep of the sea so that the pressure increase on their body. Now when these persons are going for the climbing purpose, trekking purposes, they are going upward direction so that the pressure drops, atmospheric pressure gradually drops, so that when pressure drops on their body, whatever the oxygen they inhale, that may not dissolve in their body because pressure on their body decreases. When sufficient amount of oxygen is not dissolved in their body, automatically they don't get more oxygen for their biological activity purposes, and the thinking of the persons gradually decrease. So it gives some uncomfortable and not able to see clearly also. That is called the anoxia. So these are some conditions. There we can see the application of the Henry's law. And regarding the questions of the Henry's law, we used to see that the mole fraction of the gas is there. Whenever you see some questions, we know that mole fraction of the gas is nothing but number of moles of the gas divided by number of moles of the gas plus number of moles of the solvent or solution. Solvent we take it. Remember that if you want to solve the question early and get the approximate close answer, then try to avoid to take the number of moles of the gas. So directly take the mole fraction of the gas is equals to number of moles of gas divided by number of moles of the solvent. Why we are avoiding means the number of moles of the gas, the solubility of the gases in the liquids usually shall be very less. So if you take this value also, that is negligible when compared to the total number of moles of the solvent. And if you add that, you will get the fraction values and it becomes difficult to solve the question. So that avoid the taking number of moles of the gas in the denominator, so that directly you can get the mole fraction of the gas. So dear student, this is today's class. I hope you understand. We shall meet in the next class. Thank you one and all.